Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast.
Welcome back to Application Security Weekly. We just talked with Himanshu Dwivedi about Pseudo APIs and why the basics of app inventory and Layer 7 security should be the strategic focus of today that pull us out of the AppSec struggle of the 90s. This is the news segment where we put the AppSec perspective on programming. I'm your host, Mike Shima, and I'm here with Adrian Sanabria. Let's see. We also, as always, have two quick announcements for you. Please don't miss any of your favorite Security Weekly content, and you can do that by visiting securityweekly.com/subscribe to subscribe on any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, chat with us on Discord as we do the show, and follow us on social media and our streaming platforms. And we have something new. CRA's Business Intelligence Unit has launched its next survey on Zero Trust. What are your barriers to Zero Trust implementation? ? Take our survey and enter to win a $500 Tango card by visiting securityweekly.com/zerotrust. Report results will be released at our upcoming Zero Trust eSummit in March. And Adrian, that was a lot of repeating Zero Trust, which I have to admit in our last segment, we didn't use the phrase, but a lot of what, Himanshu was describing was the principles behind the Zero Trust model, in the sense of identity and what permissions you have. But very pleasantly, we avoided the marketing angles of it and overloading what that term might be. So I thought that was pretty fun. It was nice to have you there with us.
Yeah. I often think of Zero Trust as the principle of least privilege, which is ancient, going back to like the colored, orange book and orange stuff book, like that. I think that principle was first laid out in the 70s. And yeah, but it's the first thing to go when you're in a rush, right? When you're building something quickly, trying to release it quickly, it takes time to go through and figure out exactly what permissions everything needs.
Yeah, and I think, speaking of the 70s and a bit of history of AppSec, I've got some articles at the end of the segment that we'll dive into the 90s. But before we do that, there's some very modern problems that we're still running into. I think Himanshu also mentioned this, that bugs are always going to exist, and we're going to have to deal with them. It's just kind of interesting to see where the bugs come from. And the very first one I wanted to start off with was this interesting bug in IndexedDB API within Safari. And to put some context around it, Indexed.db is one of the many, many, many browser APIs that have been created to do all types of features. We've had APIs proposed from everything from having game controllers controllable from your browser to Bluetooth to different types of data stores, in this case, a SQL-like DB. But a lot of the tension comes from any of these APIs is that the browsers are still based on that same origin policy, which can be kind of creaky, but it's very important to preserve for both security and privacy. And just as you and Himanshu were kind of making the point that when you're attacking APIs, nobody needs to get root anymore. We don't need to get, administrator to go out, do our XP command shell attacks. They just want the data. And so I thought this was an interesting example of a pretty solid design in the sense of what the IndexedDB standard is, prescribes, and it knows about preserving the same origin policy, security and privacy. But here's just an implementation bug that can leak some identity. So highlighted, I think, a theme that we'll find this episode of the difference between design versus oops in the implementation, if you will.
Yeah, I was actually just having a conversation on Twitter yesterday with somebody that had observed Firefox and some web servers that were handling HTTP codes incorrectly in different situations. So it's a common problem, apparently, browsers implementing things incorrectly. It's also worth mentioning here that if you're using iOS or iPadOS, you're using Safari, regardless of what the browser says it is. So you're affected.
Yeah, the WebKit engines, and that's the distinction that can often surprise people. Which in security we like to minimize surprise as much as possible. And pretty much everything today is either WebKit, as you described, either iPad, iOS, or just Safari, or the Chrome's engine, which is what Microsoft Edge is using now. So it's an interesting, just if we've seen, talking about the history and arcs of security, seeing IE come and embrace that engines that Chrome has given us. I'm going to shift now away from the web and kind of almost the opposite end of the spectrum into a nasty Linux kernel bug that was a local privilege escalation in some of the file handling code. And the thing that I wanted to highlight on this is a little bit of maybe a frustration, if you will, because I have some links to the email that was disclosure about this, and that has some points of when it was just introduced in 2019, when it was fixed recently, and the problem is pretty much just in an if statement that's doing some integer arithmetic, taking some subtraction that creates an integer, basically out of bounds problems. And to my mind, that seems at a glance the type of thing that, wait, why didn't a compiler sanitizer, a fuzzer find this, or one of the address sanitizers or undefined behavior sanitizers and LLVM? Why didn't the compiler just complain about this perhaps, or did it? And we have so many SAST tools, how do they continue to miss things like this? And I think these are more rhetorical questions because there's a lot of subtlety to this, and I think maybe it does need that human inspection to figure out that this is an exploitable problem or not. But it's just one of those types of bugs that makes me sigh and thinks that, well, at least from an AppSec perspective, we'll have job security for a long time.
I love the difference in how each of us look at a story like this, because for you, like what you look at, you're like, okay, how did this happen? How did this get past, all the measures that try and keep vulnerabilities out of the Linux kernel? So you're interested in the application, the development process. And me, when I look at it, from the perspective of, okay, who's affected? Because I hate these priv-esque bugs where, like, oftentimes in a story, they don't give you the context or the features in which you're actually vulnerable to this. So, is this priv-esque for, default Ubuntu, Debian, for a whole bunch of distros? Or does this require some weird kernel flag or kernel module to be enabled that nobody has enabled except, these 4 developers or something like that? And in this case, it looks like it's the capsys admin privilege, which I'm not familiar with at all, to be completely honest. But when you Google it, I actually used Bing to, don't tell anybody, but I'm using Edge over here. But when I Binged it, the first result comes up, says capsys admin is the most privileged capability and should always be avoided. And then the next result says capsys admin, the new root. So, all right. So, I mean, that's a good lesson learned here, is you're only vulnerable if that privilege is given, and it looks like you probably shouldn't give anyone that privilege.
Yeah, you make a great point. In my past, I've also, overseen some bug bounty programs where some of the reports come in and they start off with, like, if the same origin policy were broken. And at that point, it's like, wait a second, okay. If like there's all qualifiers, the
right?
Planets have aligned. Mercury is once again in retrograde because that's what's haunting everything this month. But in this point, the article I linked to did helpfully point out that, the researcher, that there was local privilege escalation in the Ubuntu, the latest version, and a container escape exploits against Google's hardened COS, which I couldn't tell you what it stands for. So I think that is nice and helpful context. And to kind of your point, John and I, when we go through a lot of these articles, we mostly skip over that aspect of the CVSS score or the number, or this affects 1 million or 1 billion devices because this is just, a lookup on Google Trends or something like that. And it's more of, am I affected or how am I affected? And I think that's a good callback to that idea of context in the sense of basics of inventory, and then how much is that we were talking about with Himanshu, and then how much of my layer 7 has controlled, isolated this particular function as a service or this particular area. What data can it get to? So, yeah, great points there. So let's see. Go ahead. I was going to use that. Yeah, there we go.
We've had a collision. I was just going to say, it used to be before the cloud, privileged escalation. I'd be like, I guess we'll get to that, but somebody's got to get onto the system first. But in the age of multi-tenancy and cloud and vendors that have built on these platforms, certainly container escapes, VM escapes, become because of that, these kinds of things do become more important. So you mentioned Google's container engine there was affected by it.
Yeah, and so it's one of those things that ideally, start patching, start deploying those patches. In the spirit of who's affected, or perhaps again, how did this happen? I pulled in a really cool article, which is a bit redundant because everything coming out of Project Zero tends to be pretty insightful, pretty interesting. This one from Natalie Savanovich, talking about Zoom, and both looking at a recent, over 2001, some pwn-to-own research that came out on Zoom, as well as some analysis that she had done looking into some of the protocols and framework within Zoom. What stood out to me was near the end, maybe I'll start to create my own CVSS Picard facepalm scoring mechanism, is that she points out that ASLR just wasn't turned on initially for some of the code that she was looking at. And it's one of those areas that just, why? This has to be definitely an exasperated why. So I'm not really selling it too much, but that immediately comes to mind of why. Imagine a good Star Trek con.
Every AppSec product out there is going to throw an error on that, right? Like right in your IDE.
It is, and it's one of those things that now I'm not necessarily a fan of checklists, but I am a fan of default configurations, and a default build configuration should include turn on ASLR. If there are reasons that it's not playing well with your third-party dependencies, something like that, okay, fine. But then you have a reason, as opposed to sort of that we just forgot. So yeah, that's one of the things that stood out. Another thing was, speaking of bug bounties or this type of research, is that she mentioned having to pay roughly $1,500 in licensing fees to be able to look at these protocols and the proprietary protocols that Zoom is using. Now, that's not necessarily to say that organizations shouldn't be going down a proprietary or route or innovating or being able to choose what they want to choose. But it does point out that from the security researcher model, when you run into barriers like that of money, that tends to filter out a lot of potentially very capable security researchers. And we've seen that, for example, in iOS. Corellium is out there now to come and try to address one aspects of those problems. But I just thought those were two of the interesting aspects of this one that stood out to me, rather than just necessarily talking about Zoom itself.
Yeah, and Zoom grew. They had 10 years of growth in 1 year, so
Yes.
We can excuse this a little bit, but yeah, I didn't even realize this was a product. So the product was the MMR server, the multimedia router, which is part of Zoom's on-premises deployment, which I didn't even realize they had. So if you don't want to go with cloud for whatever reason, for latency, privacy, whatever. They have an on-premises deployment, and there's a controller and a multimedia router piece. And I didn't even know those existed. But I found it interesting that to do this research, she had to pay $1,500, which makes a really interesting point in that products that aren't just and for Security Weekly Labs, this was a challenge too, is that there's a ton of enterprise products out there that you can't even touch until you've gone through 7 sales calls, gotten approvals, written an NDA or something like that.
Right.
And then you get to lay hands on the software. So there's, and that's one of her points here is there's potentially a lot of bugs lurking in stuff like that because it's just not getting looked at because it's really expensive just to get your hands on it.
Yeah, and that's where it's going to be, those bespoke consulting companies or the teams that are participating in competitions like Pwn to Own that are going to invest in that possibly as well, because they're, these can be good targets in the sense of who's using this software, and because who's using it can lead to, we are now interested in software because organization A, B, or C has this, and that might be an attack surface that is going to be an area of surprise, and a shadow API, a shadow install, or even just known to the business team, but unknown to the security team, I think is what that underlying theme of our prior segment.
So are we in an age where if you want something secure, use a free product? If you want to get hacked, spend $1 million?
Hopefully, good question. We'll leave that answer out for our audience. Let us know on Discord, and or John will when he gets back, we'll have to pose the question to him too. I'm going to defer and just say, hopefully, we're in an era where we just have an inventory that the security knows about it. That's my fingers crossed, or my when you wish upon a star desire for this, and. Speaking of that, maybe I'll use that as a way to clumsily pull in our next article that does bring us into the cloud and about stealing administrative JOTs through post-auth SSRF. And again, this is another service that maybe not everybody is using, like Zoom MMR. This is Workspace ONE Access, but I pulled out this article not because people may be familiar, or for that matter, probably more likely unfamiliar with this particular software, but look at how the attack got pulled off and the difference between design and implementation, because it's an SSRF with an allow list. So Adrian, if you and I were on an AppSec team talking to our developers, they're building a new API, and we pulled in Himanshu as a consultant on the side to help us, probably one of our lists would be, we care about blocking SSRF, so make sure if you're handling URLs, have an allow list and just connect to the endpoints that you expect to be. Don't be surprised by, whoops, why did we get this arbitrary URL in here? But what's really neat is that, as this write-up shows, it's once again using that authority section within the URI, and basically parsing URIs can be a little bit surprising if you can throw that @ symbol in there and turn that path to then nullify or turn the origin preceding that @ symbol into the authority, meaning this is your credentials, and the rest of that path then now become the attacker influenced origin. So once again, not a pretty well known. It's not a new attack, but it's a very simple attack, not necessarily a subtle attack, but it works. And so it gets, it hits all the right things for me. So this is why I highlighted this article. It was a fun one.
It is, and it's really well written. I like how they kind of take you through how they discovered the issue bit by bit, because it really does give you kind of like a flavor of, what this kind of pen testing or hacking feels like, where you're like, well, how does this work? Okay, well, now let's dig deeper. Where's that getting, where's that variable getting built, and how is it getting built? And eventually you find the oversight is just in something that's getting concatenated, and basically blows out the allow list is how I'm reading it. Like makes the allow list pointless.
Exactly. And it ties a little bit back to when, talking about the labs and what should be part of your lab. You, in the webcast, you were talking about some of the hardware, some of the cloud usage just to set up the tools and environment for it. And another aspect of having a good lab are just references, good write-ups to refer to the attacker mindset, as you just described. And that's one of the things we do try to highlight in these articles about how to look at an application and think, well, what could go wrong? Because yes, it's handling URLs, has the allow list, but maybe there's something we could poke at here. So this is the type of thing that I would say, as part of any lab, whether it's web app focused or mobile or something else, is just having things to read, good references to learn about that attacker mindset.
Yeah. Yeah, I'm wondering how they found this in the first place, because this falls under that, bugs in really expensive software category we were just talking about.
That's true. I don't know. Yeah, that's a good question. I'm not sure if this was one of the type of things that comes out of incidentally by a penetration test for a company, and this is one of the vectors that come in. That's pretty common, and we've pulled out from several pen testing companies, just like NCC Group, et cetera, just saying, oh, by the way, we found just last episode, I think John was walking us through NCC Group's 10 ways they got into CI/CD pipelines, because basically CI/CD is designed to execute code, and surprise, surprise, if you can execute the attacker's code, it's game over, man, game over.
Yeah, absolutely.
Speaking of, and that's one of the reasons I pulled in this other, 3-paragraph article, a very short article about security engineering course. It's really just a very brief blog post, but it has a link to a security engineering book, as well as 2 lectures based on that book. And this touches on a different theme that we kind of skirted around a few times with guests back in 2021, maybe once or twice in 2020, in the sense of, how do we teach people, how do we teach new grads about application security or just information security in general? You and I were talking with Himanshu just in the last segment about the 90s, and maybe waxing poetic about what the 90s gave us, in addition to New Jack Swing, great music came out of the 90s, but also some really horrible AppSec came out of there. So what would we like to see in the 2020s to teach new grads, both on developer side, as well as the engineers, as well as on the security side, about topics? And here I think is just one of the things that touches onto this engineering book, the lectures. And I wanted to highlight this more as a call out to our listeners. What are good resources that you find now for new grads or students going through university courses now? Or are there good university courses that you'd like us to highlight that have content that could be shared and used? So it's more of that's more of my commentary on this, is that we'd love to see more and have those discussions. And I'm not sure, Adrian, if you've come across other things along this vein that you'd highlight.
Yeah, honestly, maybe some conference talks and things like that. I don't think it's often I come across university lectures, that are really insightful and useful. But I do love that they're doing this, because I think, when I work with when I mentor, when I work with my mentees, one of the things that's difficult is to give them that lens that you look through, that you get with experience over the years. And what these lectures are doing are kind of pulling people through, okay, this is how applications used to be written, through some of the history, and also looking through the attackers, from the attacker's perspective. Why they've shifted from one thing to another. Like just the story of how we ended up with ransomware is very important to understand, because it's easy to look and understand the malware or look and understand the attack itself. But if you don't understand the motivations, then you can't do that predictive thinking that you need to do to understand why security fundamentals are important and why we need to be worried about, understand what attackers are going to do next. Oftentimes when you put something in an attacker's way, it doesn't stop them. It shifts them down a different path. If you're not prepared for that different path that you just put the attacker on by doing a good job with one thing, then you're going to be blindsided.
Yeah, I definitely want to jump on what you said there too, motivations. When I do threat modeling, I really often, honestly, try to avoid the who part of it, in terms of this is this type of bad actor, this is this other type of bad actor, this is well-funded, blah, 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 and just focus on instead motivations, because I think the motivations speak a little bit more to the how and why an application might be attacked. And that will be in the sense of they're going after the data rather than they need the root, or they're going after, or they're just doing the ransomware, which you're highlighting too. And the ransomware is a good example of the motivation as well as the business impacts of AppSec. if there's one thing definitely we want to change the course of of AppSec from a decade or two ago, is to have it better tied to both engineering and the business, to describe these are your risks rather than these are just the top 10 things that you should be doing because AppSec said so. So I really like how you're making that point. Yeah. And I think that also leads us, is a good tie-in with this other article from Phil Venables. So I think this is the first one of his we covered this year. We covered 2 or 3 of his blog posts in 2021, and I'm sure since this is at part 1, I'm sure we'll at least be covering part 2 when it comes out. But this was an article about, secrets of successful security programs. And I just wanted to have 4 things that stood out to me that speak pretty much directly to AppSec and that theme that we were talking about in the last segment of doing the basics well, AppSec, inventory, authentication, authorization, for example, is that this is focusing on eliminate sets of pain, meaning make it easier for the developers to do the right thing. Give them the tools give them the capabilities within the tools they have, for example. Reduce the risk from configuration errors. I love that one, especially as we're talking about cloud security. And then one thing that I will concede, that even though we were talking a lot about layer 7 and how important layer 7 is, more so than layer 3, the web proxy default deny. So there should be that layer 3 aspect of blocking outbound connections by default, especially in the world of, I will mention it, get your bingo cards ready, Log4j most recently, but using that web proxy to say, this is what you're connecting to pull down your third-party dependencies, whether they be, your gems, your Python dependencies, for example, from your build system, or if you're connecting to third-party APIs, B2B type of APIs, you should know what those destinations are, allow those destinations, but deny all others. So those are that was what was on my mind as I was starting to read this particular article.
Well, and it's, the reason people don't do them is not because, so sometimes you get lost in the weeds, and you kind of miss these big overarching wins where you can mitigate whole classes of attacks, which is, kind of the first bullet point in this article here. But it, it can be really hard to, when you've got all these third-party products. You mentioned Log4j. SolarWinds was the same thing. Like, when you think about it, why should SolarWinds be allowed to talk out on the internet to anything other than, whatever SolarWinds patch server or update server is? And I think everybody would agree with that. They say, yeah, okay, sure, but I've got to build it for SolarWinds, and these 1,200 other third-party products that we own. So it's a lot to kind of put that, and again, that zero trust comes into this principle of least privilege, where, I think a lot of people know it's the right way to do it, but who's got the time?
And absolutely. And one of the reasons I was also laughing is that whether you chose 1,200 to be, a bit of exaggeration or not, to me, 1,200 does not sound like an exaggeration at all. I think it's very reasonable that when, in some of the medium to especially the larger organizations, quite easily have 1,200 SaaS apps, third-party apps, B2B APIs that they're using. And
libraries.
Yep, exactly.
Gems.
It's just, that's a nightmare. Well, you know what? One NPM, one Node.js server is going to have 1,200 dependencies right there. So, game over just from that.
Yeah, and that's really where I'm hoping we see some movement on the vendor side, because that is totally a problem that vendors can go after and kind of ease that pain on people. But the other thing I love about this Phil Venables article that's kind of related to that the security engineering course, your last story here, is that this change in thinking again for management here. Whereas the previous one was more about people just getting into security, training them up. This is more for management. And I think the most important takeaway here, it's great that he's got very specific examples of where people win with security, they get good outcomes. But also the fact that big bets, and kind of going after the security culture and sticking to your guns there, staying focused on these a smaller number of big wins really is important, because since security touches everything, people will come to you for everything. and it's really tough to manage. It's really easy to lose sight of a couple big goals, in when people are pulling your attention away for literally everything. I mean,
yes,
security programs cover a lot, too much.
Totally. And I think if I have one goal this year, it's to make bug ops become one of my catchphrases, perhaps, because it ties into that idea of, as a security org, you can spend your time doing a code review, doing another code review, doing a design review of a doc, or you can say, chase particular bugs, chasing like that, or you can do something strategic to repeat what you just said about, what if we get rid of an entire vuln class because we deployed a particular framework, a particular tool, or we did something more strategic? And that's where I'm going to sandwich that Venables article with the security engineering course, as well as another article looking back, celebrating 20 years of trustworthy computing for Microsoft, because we actually have one example at least of an organization that said, Bill Gates came out and said, we've been hit with NINDA, we've been hit basically with all of the things that made the consulting in the 90s so easy with %2e slash and // command shell. I loved the era. It was so easy. Bill Gates said, we need to get rid of this double decode, these code red IIS. We need to do trustworthy computing. And it'd be interesting to look back at that and see. Yeah, exactly. They cleaned up IIS, but we don't have John here, so I'll channel my John and say, they need that trustworthy computing perhaps for Azure now, and perhaps all the cloud service providers do. So, cloud security or a security program can't be static either. You can harden your web server, perhaps. You can do some hardening of your operating system, but you still have those legacy aspects where we still see, all these, kernel drivers that printer drivers, for example, still plaguing Windows because Windows made that contract to run code that existed 20 years ago.
Yeah, actually, the Azure team, I forget his name, but they got somebody new into security leadership over there, and a lot of people are hoping he can kind of turn things around there, because clearly a lot of stuff leaked through. It was almost I don't know about ASW, but in ESW, the Enterprise Security Weekly podcast, almost every week we had. And it was Wiz or Orca, somebody, or Lacework, somebody like that, finding new issues in Azure, new vulnerabilities.
Yep. Yeah. Orca, between Orca and Wiz, they're focusing on all of the cloud service providers for sure. That brings us where we do have to wrap up as we get to the end here. I did want to throw in just a quick reference to the HTTP 1.1 spec, mostly just to say it came out in January 1997. And it's always interesting just to look back and say, 25 years later, we're still, almost all of the web apps we're using, still using HTTP 1. That's still what we're inspecting. And you made a comment earlier, Adrian, about web servers that aren't quite responding correctly or responding in weird ways, let's say, to different response codes, different requests. And so I wanted to highlight that the protocol to say, for you researchers out there want to find the next, for example, request smuggling, or want to do some fuzzing, or, for example, I will mention begrudgingly Log4j again, if you're looking for those dusty corners of the HTTP headers that may have been implemented at one point but are so rarely used, possibly have some vulnerabilities just because they've never been exercised well, going back to the specs is actually a great thing. So that's why I wanted to say it's not just there as a sense of historical trivia, but I think it can inform some fuzzing, some really corner case type of security testing that maybe we'll see some cool security presentations come out of those dusty corners of this protocol this year. Fingers crossed.
And you can bookend it with HTTP 2, and there's a lot of stuff that goes uninspected on the HTTP 2 side. Like one of my favorite data exfiltration tools is Merlin, which uses HTTP 2 to get past security products and controls.
There we go. Perfect way to bookend our podcast. And I have to say thank you again for joining us this week, Adrian.
Yeah, it's always fun to be here. I enjoy it.
Want to, we'll hope to see you again as well. Hope to see John. Thank you to all of our listeners. Remember to subscribe to the show, check out the show notes. And speaking of history and things that came out in January, go listen to some Synthwave. Laserhawk's Red Line came out in January 2010. And with that, we'll see you next week on Application Security Weekly.